Hello students, welcome back to Current Electricity. So in the last few sessions we have seen Kirchhoff's current law, Kirchhoff's voltage law. Today we will just do some more problems on Kirchhoff laws, then how to find equivalent resistances using Kirchhoff's laws. We have seen Wheatstone's bridge, then using Wheatstone's bridge, balanced Wheatstone's bridge concept, we can find equivalent resistance. Then we have seen potential method, infinite ladder method, symmetry method, all these. Okay, so using all these methods we can find equivalent resistances. But there are some problems. These methods we cannot apply. We won't get answer just by applying these methods. But those problems we will get answer using Kirchhoff's laws. So those questions also we are going to see today. We have seen nodal analysis, mesh analysis in the last class. Nodal analysis is KCL, just if a node is there, entering current, leaving current, using circuits. We find the node voltage, then we find the branch currents, that we have seen. Then loops, that also we have seen. Today, beginning of the lecture, we will see without loops, okay, from one end to another end, a part of a circuit, how to find the potential difference. Okay, so that also that we will see today. These kind of problems, okay, we will help us in some circuits, and particularly when capacitance comes, these kind of approaches will help us finding the answers. Okay, so I will start with the problems. Just I will give an introduction. Suppose if this terminal is A, this terminal is B. If this is 10 volt, if this resistance takes 5 volt, then remaining here, suppose if this is 4 volt, okay, resistance takes 4 volt, the remaining voltage at B is going to be 6 volt. So VA minus VB is how much? 10 volt is VA, 6 volt is VB, this is nothing but 4 volt. So this 4 volt is nothing but the voltage drop that is happened between these terminals. VA minus VB is the voltage drop that happened between A and B. VA minus VB is the voltage drop. Okay, that is happened between terminal A and B. So the change in voltage or potential difference between A and B is nothing but the voltage drop that is happened between the terminals A and B. Okay, clear? Suppose instead of this, if a battery is also there, if this is A, this is B, then how much is the voltage here in between? That will be the voltage difference between A and B. So with this introduction, we will do simple problems and we will make the concepts clear. Okay, clear? Note it down. Take this question, take this network, this branch. The question is, what is the voltage difference between terminal A and terminal B? What is VA minus VB? Now how to do this problem? Okay, if current is given, what we need to do is mark the current along the resistances also. Current flows from higher potential to lower potential, so mark plus minus like this. Now all the signs are ready. If current is not given, we should take a random direction. Okay, so then after that, just by assumption, we can mark a current, we can mark plus and minus. After that, when we get the result of current, based on the sign we will be able to say whether this side or this side current is. We have done like that. But here current will be giving. Okay, without current we won't be able to find. So VA minus VB, if we are starting from here, if this is the path, it is our wish which path to choose. If it is from VA to VB, it is easy if you start from A. If it is VB to VA, then it is better to start from B. So VA minus VB, when we take VA minus VB, we are assuming that actually potentiality A is greater than potentiality B, but actually potentiality B is greater than potentiality A because current is moving in this direction. But whichever way we take, it is not a problem because we will get the correct answer. Just see, VA, we are proceeding like this. Current is flowing in this direction, so this is going to be 10 volt, this is going to be 10 volt. V is equal to IR. V is equal to IR. So current is 5, R is 2. Here also current is 5, R is 2. So VA plus 10 minus 10, so plus minus minus 4, minus plus, so plus 10, minus plus, so again plus 10, minus VB is equal to 0. Now VA minus VB is how much? Here 30 minus 4, 26. This side this becomes 26 volt. Minus 26 volt. This means that potentiality B is greater than potentiality A. We have taken VA minus VB is 26. So suppose VB minus VA is nothing but 26 volt. This is the answer. Suppose if we take the path in the opposite order, suppose same question, if we take the path in this direction, okay, then we will start with the VB plus minus, so minus 10, plus minus, so again minus 10, minus plus, so plus 4, minus 10, so plus minus minus VB minus VA is equal to 0. Now see, VB minus VA is equal to minus 30 plus 4, we get minus 26 this side, go to that side, 26 volt. Clear? This is how we should find the potential difference in a branch of resistance. Clear, all of you? Take this question. This is a part of a network. This terminal is A. This terminal is A. This terminal is C. This terminal is B. What is the potential difference between A and B? Potential difference between A and C. So, how to do this? So, I mark a path. Okay, I mark a path. So since it is VA minus VB, VA minus VC, I am taking the path like this. One path I am taking like this. Current direction is given. So plus minus, plus minus, plus minus. Okay, this is the convention which we are following. Clear? Now we will apply. Okay. VA minus, this is going to be 5 volt. See, question is in black ink. I am writing the extra markings in red just because we should not get confused with the question data and our application. So this is going to be 5 volt. This is going to be 10 volt. 5 into 2. V is equal to IR. V is equal to IR. Here this is 4 volt. V is equal to IR. Here this is going to be 6 volt. V is equal to IR. Clear? So every data is clear, I hope. So now VA minus 5, VA minus 5 plus minus minus 10 plus minus minus 10. Here minus 4 minus 10 minus Vc is equal to 0. So Va, this is going to be 39 minus 39. So Va minus Vc is equal to 39 volt. This is the potential difference between the terminals A and C. Correct or what? My plus minus 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 minus. So 39 volt. What about Va minus Vb? Va minus, this is minus 5, then minus 10, minus 10 again, then minus 6, minus 4, minus Vb is equal to 0. Correct? So 30, 35. Va minus Vb is equal to 35 volt we are getting. Okay, you understood the method, right? Just mark plus minus based on the direction of current, then apply. We did Va minus 5 minus 10 minus 10, then minus 4 minus 10 minus Vb is equal to 0. So Va minus Vb we got as 39 volt. Correct? 39 volt. Suppose if we add these resistances, or if we put the resistances together, or if we separate this battery into two, okay, the end result will not change. Say for example, if I put, this is Va, this is 1 volt, then instead of giving 10 volt here, I am giving this as 5 volt, then again 1 ohm, then I give that remaining 5 volt here, then remaining things I keep it as such. So this is 10 volt, 2 ohm, 2 ohm, 4 volt, 2 ohm, and this is the terminal B, terminal A. So this is 1 ohm, 5 ampere is moving like this. So this is, instead of making this 2 ohm, I made this as 1 ohm, and I am going to connect another resistance of 1 ohm here. So 2 ohm we splitted like this, and this 10 volt we splitted like a 5 volt and 5 volt with the same polarity. So if we do like this, still we will be getting the same value. Okay, same value. So splitting the cells if we solve, and same polarity if we add, different polarity if we subtract, and if we substitute in the circuit, it will not make any difference. Clear? That also you can understand. Okay, so this circuit same as this one. This question, students, how to solve this problem? Potential difference across the capacitor 3 microfarad. What is the potential difference in this 3 microfarad? That is the question. Okay, Q is equal to CV, charge is equal to capacitance into V, potential difference. So the potential across the capacitance is important, because that is how the capacitance will be charged. Now how to find the potential across this capacitance? Pause the screen, try yourself once. Okay, pause the screen and try yourself. Now how to solve this problem? Look, this is DC, that is direct current. This 15 volt is a direct current. This is a direct current. Direct current means what? If this is time and if this is EMF, then when we give 15 volt, as time proceeds, this 15 volt will continue. Throughout, the voltage will be 15 volt. That is what? EMF, direct current. Another type of current is AC, alternating current. Alternating current. This is a separate chapter we will study. So there the current is going to have this kind of variation. Positive, negative, negative, this way, this like this. In current electricity, we are studying only direct current. Okay, all the sources are direct current. So the thing with the capacitance is, capacitance doesn't allow direct current to flow. Capacitance doesn't allow direct current to flow. So no current will flow through capacitance. Okay, now how to find the potential across capacitance? Potential difference across capacitance is nothing but, this is one terminal, this is another terminal. So potential difference across capacitance is equal to what? Actually VC minus VF. VC minus VF. This is what is the potential difference across the capacitance. Okay, clear? Now our task is to find the potential at this, in these terminals, in these two terminals. So in order to find that, we need to find the current across the circuit. We need to find the current across the circuit. Clear? So first what we will do, we will remove, no current will flow through the capacitance circuit. No current will flow through the capacitance circuit. So first I am removing this. Now this 3 plus 3 is 6. Okay, this 3 plus 3 is 6, that is in parallel with this 3. So I can say 6 ohm parallel with 3 ohm. So this, both of them together contributes 2 ohm. This together contributes 2 ohm. 6 into 3 by 6 plus 3. That is nothing but 2 ohm. That 2 ohm plus this 3 ohm gives 5 ohm. 2 ohm plus this 3 ohm gives us 5 ohm resistance. So the circuit will become like this. This is 15 volt and this is going to be 5 ohm. So current I is equal to V by R. What we are getting? 3 ampere. So 3 ampere current will be flowing here. Correct? 3 ampere current will be flowing through the circuit. So 3 ampere is flowing. 3 ampere is flowing. So if 3 ampere is flowing, this will have more resistance, this have less resistance. How? This is 6 ohm, this is 3 ohm. Okay, hope you noted all these. I found the equivalent resistance and I found the current. So if 3 ampere is flowing means this is 6, this is 3. So how to find the current through this branch? I through 6 ohm is nothing but 3 ampere into this 3 ohm divided by this 6 plus 3, that is 9. So if we cancel, this is going to be 3 ohm, we will be getting 1 ampere. So 1 ampere current will be flowing through this and the remaining 2 ampere will be flowing through this. Here again 3 ampere will be flowing through this. So what we are getting, this is going to be 9 volt, 1 ampere is flowing, so this is going to be 3 volt. Okay, now as per our basics which we have studied today, we will apply that and we will find the potential across the capacitance. So VC plus minus, this is minus 3, then here minus 9, then minus VF is equal to 0. So VC minus VF is nothing but 12 volt. So 12 volt is the potential difference across this capacitance. Clear? Okay, this is the answer. Now this was the circuit. Current across this is 0. So voltage across this R is nothing but 0. No drop here. That is why we took this terminal and this terminal. Clear? Take your next question, students. This is our next question. So here a circuit is given. Energy stored in the capacitor. That is the question. 4 microfarad capacitor is given. Energy stored in the capacitor. What is the answer? Options are given in joules. So we know, okay, so the idea is energy stored in the capacitor is nothing but half CV square. Hope you must have studied that in potential and capacitance chapter. So half CV square. Okay, this formula is half CV square. Capacitance, that is given anyway. What is this voltage? Voltage is the voltage across the terminal of the capacitor. So if this is the terminal of the capacitor, we can say this is also terminals of the capacitor. Okay, so half CV square. So again, just like the previous method, if we understand the voltage difference between these two terminals, okay, then we will get the answer. Okay, so you can name this as, okay, just name this as A, okay, this as C, something if you name, and then just find the voltage difference, potential difference across the terminal A and C. Whatever potential we are getting, if we substitute here, we will get the answer. Okay, pause the screen and try yourself. Okay, I believe you know this now. Okay, so how to do this? Now you are ready with the answer, right? Now we will verify. 1 ampere is coming, 3 ampere is coming, so definitely this is going to be 3 ampere. No current will flow through this because this all the sources are DC. Okay, direct current will not pass through capacitor. So 3 ampere, 3 ampere. So plus minus, this is going to be 15 volt. Plus minus, this is going to be 3 volt. V is equal to IR. And it is coming. 3 ampere is coming. Now here another branch is going. So we cannot say this is 3 ampere itself. But here they have given 2 ampere. This is 2 ampere is given. And 1 ampere is coming like this. So definitely this must be what? 1 ampere should come like this, then only this 1 ampere, this 1 ampere will give 2 ampere. No current this branch, no. So 1 ampere is coming, we can fix 1 ampere is coming. So this is going to be 2 volt. Now everything is ready. Now we will apply VA minus 15 minus 3 minus 2 minus VC. C, okay, is equal to 0. So VA minus VC is how much? 20 volt. So substitute here half into, what is the capacitance? 4 microfarad. So 4 into 10 raised to minus 6 into 400. Correct? So this is 2. So what we are getting? 8 into 10 raised to minus 4 joules. Correct, no? 800 into 10 raised to minus 6, but we are getting 8 into 10 raised to minus 4 joules. Clear? So the method which we have studied, a part of a circuit, how to find the potential difference between them. Already this is an understandable concept, but we have discussed it separately so that we will not get stuck anywhere. Okay, note it down. Students, so next topic is finding equivalent resistance using Kirchhoff's law. Okay, finding the equivalent resistance, a category of questions we have done already. Now certain questions we cannot find its equivalent resistance using the methods we have learned. So sometimes you will have to use Kirchhoff's law. So how to do this? Okay, so first what we should do is, first step is connect the imaginary battery of EMF V volts across two terminals across which we need to find the equivalent resistance. Suppose if we need to find a resistance, okay, something like this. If you need to find the resistance, this one we can find easily, but I am taking this as an example. So across A and B, if we need to find the resistance, according to this method, what we need to do? Connect a battery. Okay, that's it. Across the two terminals where we need to find AB. This circuit I have taken as an example. This circuit we will find in no time the equivalent resistance. But as an example for this case, I have taken this. Okay. We need to find the equivalent resistance across AB. What we need to do? Just connect an imaginary battery. Second step is draw current from the battery and distribute with the minimum variables. Say suppose draw current I. So current I is here. So if this is I1, if we want, we can draw this as I2. We can put this as I2. So how many variables will come here? I is one variable, I1 is one variable, I2 is another variable. So instead of putting I2, what we can do here? I minus I1. So we have restricted here as two variables. So likewise with the minimum variables, just distribute the current. Then calculate current across different resistors. So likewise, whichever branches are there, distribute the current like that. Sometimes I minus I1 plus I may come, plus I2 may come likewise. After calculating different currents, take a loop including battery and minimum resistors and apply KVL. That is, we can apply a loop like this. So this battery is involved and minimum resistance. This is one resistance. So this is minimum resistance. This loop is what we can select. We can take this loop also. Closed loop only KVL requires. So we can take this outside closed loop also. This is also closed loop. But here includes this resistance, this one, this one. So it will take the calculation to another level. We may lose time. So take a loop with the minimum number of resistance. That is what. Then once if we do that, apply KVL, write in this way. V is equal to I into R equivalent. Okay, we will be getting like this. R equivalent is equal to V by I we can do. Okay, these are the steps. Now we will do problem and see. See this question. Okay, so here we need to find the equivalent resistance between the terminal A and B. Okay, find the equivalent resistance between the terminal A and B. So what is this? This is actually Wheatstone's bridge. And whatever Wheatstone's bridge we have seen and we have solved equivalent resistance or all are balanced ones. Just this by this is equal to this by this. That is what balanced Wheatstone's bridge. But here this one by this is not equal to this by this. So this is an unbalanced Wheatstone's bridge. Clear or what? This is an unbalanced Wheatstone's bridge. Unbalanced Wheatstone's bridge. Okay, so first I will show you a method using KVL direct method, and same these type of questions using another derivation we will get an expression. So if we get this question in Neet and JEE, we cannot spend so much time in deriving the answer. So we should apply the values in the formula and we should get the answer. That I will tell you at the end. Now we will see how to solve this problem in the direct method. See, according to the instructions or according to the steps, what we should do? First we should connect an imaginary battery with the voltage with the EMF V. Now what we should do? We should mark currents. So if this is I, we should give two currents across these two. So suppose if I give here I1, if I want I can give here I2. In order to reduce the number of variables, what I am doing, I am giving here I minus I1. Whatever is coming here, if a part goes here, remaining will be coming here. So I minus I1. So this is I1. Now here I have to divide again. So I am giving here I2. So this is going to be I1 minus I2. I1 minus I2. So I2 is coming here, this current is also coming here. So this is going to be I minus I1 plus I2. Now all are coming here. Finally what happens, whatever entered here will be leaving here. I minus I2 plus I1, here this is I, okay, I minus I1 plus I2. So finally if we add these, you can see everything will get cancelled off, only I will survive, so that will pass through this. Clear? This is what. Now if we take loops, for first loop, second loop, we can find the value of currents. So according to the last step, we should select a loop, okay, with the minimum resistance. Minimum resistance, why minimum resistance? Because that will make our task easy. So there are many closed loops here, okay, A between B, okay, A, likewise closed loop. So one loop is A, B, C, D, B, A, A, B, C, D, B, A. Another loop is A, B, A, E, F, G, B, A, A, E, F, G, B, A. Likewise, third loop is, again third possibility is there, A, B, C, F, G, B, A, A, B, C, F, G, B, A. Here two resistances, here also two resistors will come, here three resistors will come. This loop contains three resistors, 1, 2, 3, otherwise 1, 2 or 1, 2. So I am choosing this loop, okay, A, B, C, D, B, A, okay, this one, A, B, C, D, A. So if we take this loop, then applying KVL, so this is going to be plus V in this direction. In this direction we are taking this loop, we are taking, okay, which one? Here, not this one, this side we don't touch, or I will show like this, okay. Okay, so minus plus V, then here current is moving in this direction, so we will mark the current direction as such. We'll mark the current direction as such. So plus minus, then plus minus, likewise if we take, so V minus 2 I1, then here minus 4 I minus I2, then what? Equal to 0. So this is our loop, okay. This 2 is resistance, 4 is resistance, I1 is there, I2 is there, I is there, okay. So now what our task is, we need to substitute for I1 and I2 in terms of I. So what we will do, we will take this loop, we will take this loop, we will make two equations, and we will find the value of I1 and I2 based on I. Clear? Then we will substitute, we will get the answer, okay. So note down till this. So loop 1, so here everything is marked clearly. This is I1, very clear. This is I2. We need not take like I1 minus I2 and all. Every currents are very clearly differentiated. Just we need to apply the loop, nothing else. Okay, so first loop, if we take minus 2 I1, clockwise I have considered. So minus 2 I1, here minus 2i2. Current direction is given like this, plus minus 2i2. If we come here, current direction is here. This is not like our previous loop. Every current direction is clearly marked here. Okay, so just follow the current direction when we take the path. So this is going to be, since the current direction here it is plus minus, here it is going to be plus minus. So minus 2i2 here plus 4 into I minus I1 is equal to 0. So this is loop 1. So we can write minus 2i1 minus 2i2 plus 4i minus 4i1 is equal to 0. So finally we are going to get minus 6i1 minus 2i2 is equal to minus 4i. So removing the signs and dividing the equation by 2, we will be getting 3i1 plus i2 is equal to 2i. Correct? Dividing the equation with 2. So this is one equation we got. Okay, let it be there. Clear how we took loop 1. Now I am erasing that. Okay, this step I am going to erase, note it down. Now I am going to take loop 2. I am going to take loop 2. Loop 2. I will take clockwise. Current directions, everything is marked. Only this current direction we need to mark. Current is in this direction, I minus I1 plus I2, so plus minus. Remaining everything is clear. Right. So here plus minus, so minus 4 I minus I2. Here minus plus, so plus 2 into I minus I1 plus I2. And here if we go, then minus plus, so plus 2 into I2 is equal to 0. Expanding, minus 4i, this is actually I1. Correct? I1 minus I2. So minus 4i1 plus 4i2 plus 2i minus 2i1 plus 2i2 plus 2i2 is equal to 0. So what will be getting? Minus 6i1 then plus 8i2 is equal to minus 2i. So dividing with the 2 and just arranging the signs, plus minus to plus, we will be getting 3i1 minus 4i2 is equal to I. Correct? So this is the equation 2. This is equation 2. Note it down till this. Okay, I am erasing this loop 2. So we got the equation, both the equation. So equation 1 and 2, if we write 3i1 plus i2 is equal to 2i, and here it is 3i1 minus 4i2 is equal to I. So if we, this is equation 1 and this is equation 2. So 1 minus 2 if we take, this is going to be 5i2 is equal to I. So we got I2 is equal to I by 5. I2 is equal to I by 5. If we substitute in any of the equation, we will be getting the other one. So 3i1 plus I by 5. Okay, 3i1 plus I by 5 is equal to 2i. So 3i1 is equal to 2 minus 2i minus I by 5. So this will become 10i, 9i by 5, it goes this side, and finally you will be getting I1 is equal to 3i by 5. So we got I1 and I2 values. Now we will substitute in the main equation and we will get the answer. Okay, note it down. I am clearing this. Okay, so V minus 2I1 is equal to 3I by 5 minus 4 into I1 is 3I by 5 minus I2 is I by 5. So V minus 6I by 5 minus 4 into, this is going to be 2I by 5, this will become 8I by 5 is equal to 0. Okay, so V minus I by 5, if we take common, this will become 6 plus 8. Correct. Now if we take minus I by 5 outside, this will become 6 plus 8 is equal to 0. Okay, so here we will be getting V minus I by 5 into 14 is equal to 0. Okay, so V is equal to 14I by 5. So V by I is equal to 14 by 5 we get, which is nothing but R equivalent. Clear? So what we are doing here is, we will connect an imaginary battery, then we will take a loop. Taking the loop is to get V by I. V by I of the whole circuit is nothing but the R equivalent. Equivalent resistance across the terminal is what we are finding. So across the terminal we take a loop. We mark V, we mark I. If we take V by I is nothing but R. So simply we may not get directly the V by I. When we divide the currents like this, I1, I2 will be there. So this I1, I2 will have to convert into I. So that is why we took two loops and we took two equations and we found I1 in terms of I, I2 in terms of I, so that when we take V by I, we will be getting the answer. Okay, so please note it down. I will give a formula also for these kind of circuits. See students, for unbalanced Wheatstone's bridge, okay, look at this is the question we got. Okay, we need to find the equivalent resistance between the terminals A and B. That was the question. So see, 2, both are same, 4 and 4 both are same. So these kind of questions, unbalanced Wheatstone's bridge with this kind of setup, we used to get normally. This we can see in many places. So in these kind of things, if you try to apply KVL, applying EMF, taking the currents, if you do all this, we will be able to do maximum 1 or 3 questions in Neet or JEE. We cannot spend so much time in competitive exams. Board exam fine. Okay, in competitive exams we don't have that much time. So if we try to find R equivalent, okay, just by proper derivation, we will get this formula also. Okay, this is not just a shortcut, just through derivation itself we can get this formula. So just see this. If these resistances, if we consider as small r, the middle one 2, 2, 2, okay, 4, 4, R. So use this formula to find the equivalent resistance. Small r into 3 capital R plus small r, divide by capital R plus 3 small r. In this question we got R equivalent how much? V by I and all we did, and we got 14 by 5 we got. Now look at this. R equivalent is equal to small r is what? 2 here. Into 3 into capital R is how much? 4. Plus small r is again 2. Divide by capital R is 4. Small r, 3 into small r is 2. So when we do this, we will be getting 2 into 12 plus 2. Divide by 4 plus 6. Okay, so if we do this, this will be 5 and this is 14. So we will be getting 14 by 5, same answer. This, if you remember this formula, hardly it will take 10 seconds or 15 seconds, same problem. Okay, note it down. You see here, this is a cubic structure. We need to find the equivalent resistance between the terminal A and B. Cubic structure with the resistances, same equal resistances everywhere. Okay, we need to find the resistance, equivalent resistance between the terminal A and B. So can you try this? Just pause your screen and try this question. Okay. So again, we will be connecting a battery across the terminal. So if I is passing like this, okay, here it is dividing, same I will come out. So from 3 resistances, so I can take this as I by 3, I by 3, I by 3. So here also same resistance, this is symmetric, I by 3, I by 3 and I by 3. After reaching here, this will divide into 2. So I by 6, I by 6. Here I by 6, again I by 6. So here again I by 6 and I by 6. So I by 6 is coming, I by 6 is coming, I by 3 it becomes. Then I by 6 is coming, I by 6 is coming, this becomes I by 3. I by 6, I by 6, this becomes I by 3. So totally it becomes I. Clear? So immediately we got everything. Since this follows symmetry, it is easy for us to follow. So 1, 2, 3. And if we take this loop 1, 2, 3. Okay, or otherwise 1, 2, 3. Many loops in any way we can take, but it is better to take the better visible thing. So what I am going to do is, in the direction of current, will mark plus, minus, plus, minus, plus, minus. This loop I am going to take. We will name the loop A, C, D, F, B. Okay, likewise we will take. So loop A, C, D, F, this is B, A. This is the loop which we are going to take. So now apply KVL. V minus R into I by 3. When it comes here, minus R into I by 6. Here minus R into I by 3 is equal to 0. Okay, so we will take LCM. So LCM will be what? 2. So 2V minus LCM is 6. So 6V minus 2RI minus RI minus 2RI is equal to 0. This will go there. So 6V is equal to 5RI. So V by I, if we take, what we will get? 5 by 6R will be getting. 5 by 6R. So from this we will be getting R equivalent is equal to 5 by 6R. Clear? So same question you can see in HC Verma. We'll get this question in HC Verma also. HC Verma exercise. Answer is given. How to do this is not given. Solution is there in the book. See students, similar questions. Okay. These two are worked out examples in HC Verma. These two are worked out examples in HC Verma. This is given in the exercise. This is not worked out, but we have worked out. And you can see this question steps also in the book. So here we have got the answer 5 by 6R. This is body diagonal. The diagonal of the entire body we have taken as the terminals. This is face diagonal. This is a face. This is one diagonal. This is another diagonal of the face. R equivalent is 3 by 4R. This is two terminals of a face. Okay, not diagonal. Otherwise, A and B. 7 by 12R. Okay, these are the answers for this question. These two are worked out in HC Verma. This one is the exercise question. Note it down. Take down this question. Okay, we need to find the current across R1 and R2. Current across R1 and R2. This is JE 2019 mains question. Now how to find this answer? So pause the screen and do yourself. Pause the screen and do yourself. So conventionally in your board exam or according to the syllabus of +2, the method which should do is nothing but using KVL. That is, we can take a loop like this. This can be I1, this can be I2. So if it is marking like this, plus minus, if you do like that, then this is I1 R1 minus, I1 minus I2. Okay, how to do? Consider this as superior current and this is inverse. So I1 minus I2 minus we can put, since we are considering the direction like this, R1. Then minus 10 equal to 0. So minus I1 R1 plus I2 R1 equal to 10 we can write. Okay, so this is one equation. Here we can take another equation. So this is nothing but I2 minus I1. So this is the direction we are considering. So minus R1. Okay, then here minus I2 R2 plus 10, okay, equal to 0. So we can do minus I2 R1 plus I1 R1 minus I2 R2 is equal to minus 10. Clear? Likewise, two equations we can form. R1 R2 values we know. Okay, R1 R2 values we know. Okay, we can substitute R1 R2 values. The only unknowns here are I1 and I2. Okay, solve this, you will get the answer. Okay, this is the direct method. You can solve this. Get the answer, make it ready. Now verify answer with this method. Already we have seen similar questions. No resistance in this circuit. So minus 10 volt is this. So we can consider this as minus 10 volt. Correct, no? So minus 10 minus 0. Okay, so minus 10 by 20. So this is going to be 0.5 ampere. Minus 10 divided by 20 is 1 by 2. So 0.5 ampere. So here if we consider this as 0 volt, the direction will be this. What about this one? Minus 10. This is minus 10 of minus 10. Minus 10 of minus 10. Because this is also, this is actually, the polarity is this. Minus 10 polarity is this. What about its polarity? Again this one. If we took, so this will become cancel out now. This will become cancel out. 0 volt is the effect. So 0 current in this branch. So if we use this method, you will get the answer in 5 seconds or 10 seconds. Take this voltage to the node. 10 minus 0 by R. 10 minus this 10 by R. Since these both are opposite polarity, that will cancel out. JEE main question, you can answer this question in 5 to 10 seconds based on the nodal analysis method which we have discussed in the class. Clear? Note it down. So this will take more than 1 minute, I feel. This will take some time. And if you follow this method in your school or board exam, I think they may not give the answer because this is not in our syllabus. Nodal analysis, I think this is not there in the syllabus of board exam. Even this is not there in the syllabus of Neet also. Okay, this is an alternate method to get the answer easily. Okay, so consider like that. So students, if we use nodal analysis, it is easy. Even if we put a resistance here, then also we can use this problem with one equation. If we use mesh analysis, if we do KVL, we will get two equations, two unknowns. We will have to solve all that. So be ready with the nodal analysis. Difficult problems we can solve in few seconds. Then that cubic cube network. Okay, all the three types we have seen today. How to solve a question using a KVL and unbalanced Wheatstone's bridge. The shortcut formula also we know. So with this KCL, KVL is done. Take any question, any complex question, any difficult question from any book, and with these basics you try. Okay, so I strongly suggest you take advanced questions also, okay, of current electricity, okay, and solve whatever we have covered and come to me with the doubts. Okay, then now the pending topics will be a potentiometer, then practical voltmeter and ammeter we will see. Okay, so these topics are there. Then power energy analysis that we will do in the coming sessions. Okay students, goodbye, good luck.